Hi, the topic is Bresenham's circle drawing algorithm. In this lecture, what are the topics that we are going to discuss? First, we will understand what are screen coordinates. Then we will see how to draw a circle on the screen using polar coordinates. But for drawing it using polar coordinates, there are some drawbacks. So we'll understand what the problem is, what are the drawbacks. Then we will go towards Bresenham's circle drawing algorithm. For that, first we will understand the coordinate system, world coordinate system, and that we'll understand what are quadrants and octants or octets. We'll understand that. Then we will derive the method for Bresenham's circle drawing algorithm, which is based on Pythagoras theorem. Then after that, I'll take one example problem and show you how to draw a circle based on Bresenham algorithm. Then also I'll show you the program code. So these are the topics that we are going to learn. Now, one important thing. I have some courses on Udemy. You can check the link. It's given in the description. And also I have website. On that also I have same type of courses like courses on C++, Java, Python and a data structure using C++. You can visit the website also, and very soon I am going to update the website. Now, about this lecture, one interesting thing. See, I am using animation in this lecture. Lecture is based on animation, but I am also there in this lecture. So actually it is manimation. I am using manimation in this lecture. So the interesting thing is I am using a different style of teaching here. So I need your feedback. So give your comment. And also if you want a lecture, similar type of lecture on any other topic, you can mention it in the comments. Not the subject name, just a particular topic. You can give any topic. I'll create a lecture on that by following the same presentation style or the teaching style. So let us start. First, we'll start with the coordinate system. That is screen coordinates. We'll understand how the drawing is done on the screen. See, this is our screen. And this top left corner is coordinates 0, 0, which is called as origin. And this way runs x-axis, all positives. And this way runs y-axis, all positive. Y-axis is a downwards. Usually on a graph paper, when we plot coordinate system, we take y-axis upwards, positive, downwards it's negative. But on the screen, it is positive downwards. There's a difference. So you have understood where the origin is and x-axis and y-axis. Now, suppose we want to draw a circle. At some point, let us call it as x center and y center, that is xc and yc. We want to draw a circle with some radius. How to draw it on the screen? So for drawing anything on screen, you have to glow all the pixels on the circumference of the circle. You have to glow all the pixels. So yes, on the screen, you will find grid of pixels. All these cells are representing pixels. So pixels are nothing but picture elements. And each pixel is having x, y coordinates. That is x-axis and y-axis. And these are all integers. Integer x and integer y. Now we need all the pixels on the circumference. How to get it? So for that, we can use some mathematics. So by using radius and theta, because a circle runs from 0 to 360 degrees, we can use radius and theta, that is polar coordinates. It is called as polar coordinates. So let us see polar coordinates. So drawing a circle with polar coordinates. To get any pixel on the circumference of the circle, let us say x, y, we need to know what is x and what is y. For that, we can get it using polar coordinates like this. X is equals to r cos theta and y is equals to r sin theta. By using cos theta and sin theta, you can get any point on the circumference of the circle. But this will give you the point x, y with reference to the center on the origin, not here. Not here. So for that, we should add the center to these x and y. So we'll add xc and yc. xc plus r cos theta, yc plus r sin theta. Now what is theta? Theta is the degree or the angle in a circle that runs from 0 to 360. Now placing the values here, the theta value you can start placing from 0 to 360. So if you put 0 here, you may be getting this x comma y, and if you change the values, you'll get next pixel and next pixel. You can go on getting the pixels by changing the values here, and you can go up to 360. You get all the points on the circumference of the circle. Total how many points you'll get? You'll get 360 points only. If the circle is smaller in radius, then it's okay. If it's very big, then you may not be having sufficient points. You have to draw a circle just with 360 points. So you may be having gaps in between the points or the pixels. This is one problem. Now one more major problem is, if you see the circle, it's not smooth. What's the reason? Because this cos theta sin theta gives you floating values. Suppose the value is 0.7. So on the screen you don't have 0.7, but it is truncated and taken as just 0. Just as 0. After multiplying with r, suppose you are getting 5.9, then it should be 6. But no, because we need just integers, in this method we'll be truncating it and we are just taking 5. So that's why you are not getting proper pixels. That is the problem. So yes, what we can do, we can take the round value of this one. So which take the nearest value. But the thing is, when you need pixels in integers, why you are getting in float? And float arithmetic takes a lot of time. So why you are wasting time? So algorithm will be slow because of this floating point. That's it. So for that, we need an algorithm which works purely on integers. We don't want floats to get involved in this one. So we need an algorithm which works on integers only and get integer x and y so that we can plot pixels on the circumference of the circle on the screen. That's the objective. So for that, we don't need this formula which is having cos theta sin theta. We need another formula. What is that? That's what we will see. So for this, we are going for Bresenham's algorithm, but before that we'll understand the world coordinate system. In that we'll understand what are quadrants and octants. So for explanation, I'll take this graph paper. This is x-axis and this is y-axis and this is the origin. And x values are positive in this direction, negative in this direction. Y values are positive in this direction, negative in this direction. And this is called as quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Now actually, if you have seen a screen that was in this quadrant, fourth quadrant, where x was positive but y was not negative, y was also positive. So we say screen is in fourth quadrant. So these are the quadrants. Now, one thing, if you observe here, the markings are for the points, not for the cells. But on the screen, we need cells. That's what the difference you should know. Now, first we will see how to draw a circle here on the graph paper in this coordinate system. Then we derive the procedure for Bresenham's algorithm. Then we will see how to draw it on the screen. So let us start. See, suppose you want to draw a circle at this point 10, 10 with some radius, let us say 7. So we get a circle like this. So now we know the points on the circumference of the circle. We should find out all the points with using some other methods. That is nothing but Pythagoras theorem. But one thing you know, that you get the points not with reference to this center, but with respect to origin. So we'll bring the circle on the origin, center on the origin. Now, once you bring the circle here, if you observe, the circle is symmetric in all four quadrants. This portion, and if you say the same amount of the circle is in this quadrant also, this quadrant. So, for drawing the entire circle, if you just take 1/4 of a circle, that is sufficient because it's symmetric. For example, if you have a point here at 2, 7, then you can get another point here also with reference to this origin. You can get another point in this quadrant also, that is -2, 7 in the second quadrant. In the fourth quadrant, -2, -7. You are just changing the signs of this one. and you can get the point on this quadrant also. So if you know one point on the circumference of the circle, you can know 3 more points, total 4 points. But there is one more observation. If you see here, if you take a 45 degrees here, now this piece and this piece is also symmetric. Now I have 2 comma 7. If I take 7 comma 2, where it will come? 7 comma 2, here it comes. That's also on the circumference of the circle. So it means with that point also I can get minus 7 comma 2, and in this quadrant also I can get the point. On this quadrant also you can get the point. Now you can see that circle is not just symmetric in 4 pieces, it's symmetric in 8 pieces. So we'll make 8 pieces out of this one. So it means for finding the points on the circumference of the circle with respect to origin, we don't need all the points, just we need 1/8 portion of a circle, that is sufficient. So we have reduced our work now. Before starting Bresenham's algorithm, we have reduced our work. Now using Bresenham, we have to find out only this many points. 1/8 of a circle. That's it. So now we'll move towards Bresenham. For that, I need only this quadrant. So I'll remove these quadrants. I'll remove them. Now in this also, if you observe, we are drawing a circle within this piece only with piece of a graph. So I'll remove this part also and I'll clear these things. Now I'll zoom it. So here I have one portion of a graph within which we can draw our circle. Now if you observe, this is 0 comma 0. Actually this point, intersection point, is 1 comma 1. This is 1 comma 1. This is 2 comma 1. But I am labeling this cells as 1, 2, 3, 4, not the intersecting points, because we have to fill up the cells. Anyway, on this we have to do Bresenham's algorithm, that is we have to derive Bresenham. So let us go to deriving Bresenham's algorithm using Pythagoras theorem. Now we have to draw a circle. Remaining part we'll do it later. Just we need this portion. In that also we need 1/8, that is a half of this one, but I'll keep the entire thing. Now we need to know how to get a point on the circumference of the circle. How to get that x comma y. So for that we can apply Pythagoras. How? Let us see that. See, if I say this is x and this is y, this is x and this is y, and this is radius of a circle. Now if I keep this y on this side, now this side is x and this side is y, and this is forming 90 degrees here. This is a right angle triangle. Right angle triangle. Pythagoras theorem works on right angle triangle. But actually we need x and y. We know the radius. Okay, let us apply Pythagoras on this one. So I'll take out this triangle and keep it here. Now we'll apply Pythagoras. What does Pythagoras says? It says that if you take the sides other than hypotenuse, this is called as hypotenuse, and the other two sides, if you take x square plus y square, that is equal to radius square or hypotenuse square. This is Pythagoras theorem. And if I keep r square on that side, this will be equal to 0. Now this says that if you have any x comma y on the circumference of the circle with radius r, and if you put that x and y here, the result will be 0. If you are getting result as 0, means the point is on the circumference of the circle, the other way. Now with this, we can form a function out of it. So we'll keep it here and call this as a function f of x comma y is equal to so and so. Now instead of saying x comma y, we can call it as a point. So let us make it as p. F of p is equals to this equation of Pythagoras. Now this becomes our circle function. Function for a circle. Any point on the circumference of the circle, you put that x comma y and the radius, the answer should be 0. It should be 0. Yes. Now by using this, we will go ahead with Bresenham. So let us keep this function here. Now listen carefully. Now listen carefully. What we need? The points on the circumference of the circle. In that we need what? X comma y. Do we know anything from this equation? Yes, we know. What is that? Radius, that is 7. As an example, we know that. Then what are the things you need to know? X comma y. So from one equation, can you find out two values? No, you cannot find out two values. From one equation, you can't find two values. Just you can find one unknown. For two unknowns, you need two equations. But we have two unknowns here. Then what? So if you have one equations and two unknowns, then the procedure is to get both the values, you have to sample one of the values. So what we can do is, we will sample x. Sample x means, see, within this only, we have to get x and y values. So if you see the x values that start from 0, 1, 2, 3, 4 up to 7, they will go maximum. If you're taking entire quadrant. So we'll take x here and y here. So we'll increment x. What about y? It will increment x. Now actually y should decrement now for this one. Will decrement y. So if you are sampling x values, which is go on incrementing every time, but y value will decrement. But it will not decrement always. So then you have to decide and decrement it. So if I increment x, now y is not decremented, because if you observe here for 4, y is in the same position. We don't have to decrement it. Then if I increase, now y should decrease. So here when you are sampling x, x will always be increasing. You have to remember this one. Now entire derivation is based on this. Always x will be increasing, but y will decrement, but not always. We have to decide whether to keep the y as it is or decrement it for the next pixel. This is one way. So you can know by sampling the values of x. What are the values of x? For radius 7, it can be from 0 to 7. That's it. 0, 1, 2, 3, 4, 5, 6, 7. X will be changing like this. Y, it will start from 7, then maybe 6, or remain 6, or maybe 5, or remain 5. That's how you have to decide whether to decrement y or not. Now, the other way is, you can sample y also. For that, y starts from here. Y will be incrementing every time, but x starts from here. So y will be incrementing, but x will be decrementing. And you have to decide when to decrement x or not. That's it. We will be sampling either x value or y value. So we will use sampling of x value for deriving Bresenham. Now one thing, once again I am repeating, you have this equation of Pythagoras and these three unknowns are there, but for radius we know it very well. So we have two unknowns now. So one we have to sample, that is x, and we get y. X is always incrementing, y is decrementing, but not always. Whether to keep y same as it is or decremented, we have to decide. This what is the approach that we use for deriving Bresenham. This is the basic concept, the basic idea. Let us start. Now we'll sample x values and y value. Let us start. I'll say x equal to 1, y is equals to 7. We got this pixel 1, 7. Then x will increment, x becomes 2. And y, will it decrement? No, it remains same. So we get the next pixel. Then next, see, we don't need points on radius 7. We want general formula. Now we will derive the formula, general formula. So let us call this as xk right now, which is 2, and call this as yk. So this is xk and yk based on some k, that is some x value, some y value. Now observe this. What should be the next x value? Obviously x plus 1, xk plus 1, it will move next. But what should be the y value? Whether keep the y in the same position or decrement it. This is what we have to decide. So for deciding, we need a decision variable. Yes. Once again, I am repeating. Listen this. In Bresenham algorithm, x is sampled in Pythagoras theorem. So x will always increment, but whether to keep y as it is or decrement it, we have to decide and do it. For that, we need a decision variable. So now what all you are going to learn or what you are going to see is a derivation of decision variable, nothing else. The calculations are too lengthy, but a simple thing is you are finding decision variable, which will help you to decide whether to keep y as it is or decrement it. This is the objective from now onwards. After that, we get an algorithm, we'll draw the circle. Now we are deriving decision variable, finding our decision variable. Watch this. Now the question is, y should remain there only or decrement. If we keep y there only, this will be the pixel. If we decrement it, this is the pixel. Let us call this as northern pixel, which is in the next k, xk plus 1 and yk as it is. Xk plus 1, yk as it is. Then this is called as south pixel. Let us call it as south pixel, whereas xk plus 1, x is incrementing, but y is decremented. Now if you observe, I have kept them in subscript. That means next k, next y, next k, next y. Next k is plus 1, next y is minus 1. Anyway, so we have this north and south. Now the question is, which one we should take? For that, we need to know the distance of those two pixels from this origin. So let us take the point, a center point of that pixel or the cell, and center point of this one. Now let us find out the distance. So for that, we can take the radius, but radius goes up to here only. So that point is outside the circumference of the circle. So how much away it is? This much away. Now let us take the radius. We get a circumference on here. So the point is less than the circumference, less than the radius. How much less it is? It is this much smaller. Now you can see clearly which one is nearer, south pixel or the north pixel. Which one is clearer? I'll zoom it and show you. Here you can see this one. Now radius is coming up to here. This is the circumference. So this is the distance from the circumference to the center point of that pixel. And this is the distance from the circumference to the center point of the pixel. Now one pixel is outside, one pixel or cell is inside the circumference. Now one thing for sure, the northern point may be on the circumference or outside the circumference. Means if you put it in this equation, then either you get the value 0 or greater than 0. And the southern point either on the circumference or inside the circumference, always. So when you put it in this equation, it may be 0 or less than or equal to 0, less than 0. So less than or equal to 0. This one is greater than or equal to 0. This one is less than or equal to 0. Now using this north and south pixel, let us use Pythagoras theorem. Let us bring this function there. Now here in this one, I'll put this point that is north here. So what is the x value? Xk plus 1. K plus 1, I am keeping it in the subscript to show that next k. We know that it is plus 1 definitely. I'll write it as xk plus 1 whole square. Then what is y? It remains same. So this will be just yk. Now we need for southern pixel also. So let us bring this Pythagoras function and take this southern pixel. What is that? X k plus 1 y k minus 1. So this becomes s. I am substituting. So this is x k plus 1. This is y k minus 1. So y k minus 1, x k plus 1. So I have substituted this. Now these two functions will help us decide whether to keep y as it is or decrement it. Now if you observe, already I have explained you that this function gives always positive result. Means it will be greater than or equal to 0 because the point is outside the circumference of the circle. Definitely it will not be inside. And this always gives negative or equal to 0 result. So this is negative function. The point will be either on the circumference or inside the circle. So it will be less than or equal to 0. This will be greater than or equal to 0. So one value is positive, one value is negative. So once again I am telling you, we are going towards deriving a decision parameter or a variable which help us in deciding whether to keep y as it is or decrement it. That's the objective. Now we'll continue. I'll remove this. We don't need this now. I'll take this Fn plus Fs. What happens if I add these two? You get like a positive value or negative value. We can get anything. Either we may get 0 also. 0 means what? Both the points are giving 0, 0. If you are getting negative result, means what? Out of these two, which value is greater? This value is greater. It means this distance is greater. The distance of a point, southern point to the circumference is greater than northern point. If you are getting negative result out of this one. So who is closer? Northern pixel is closer. So whoever value is greater, you will get the result based on that. If you are getting negative means this is greater, positive means this is greater. So if the result of this by adding these two, if it is less than 0, means this southern pixel is greater, means it's far away from the circumference. So we should select which pixel? We should select northern pixel. Means what? Y should remain there only. Y should remain there only. You should not change Y. Otherwise, if this is greater than or equal to, we'll include equal to also. We have to include equal to on any one side. So we'll include here. If it is greater than or equal to 0, means it's positive. Then which pixel is far away from the circumference? Northern one. This is bigger. So who is closer? This is closer. So we'll select southern pixel. That's it. So we will call this as a decision variable which help us selecting whether north pixel or south pixel. So let us call this as dk, decision variable k. You can also say in textbooks you will find it as pk. I'm calling it as dk. In some textbooks you will find it as dk. dk is a decision variable for which position? At some kth position. At some kth position. We are right now at some xk and yk. At that position, whether to keep y as it is or decrement it. Who will help you? This addition of these two functions will help you. That we are labeling it as dk. We have to derive this one now. So let us take this here. dk is equals to fn plus fs. Means we have to add these two. Have we added and got the result? No, we have to do that. That's what the derivation is. So, but this becomes a decision variable. What does it says? If dk is less than 0, then we will select northern pixel. Northern pixel. So for that we will say xk plus 1 means we'll increment x, but y remains the same, yk. If dk is greater than or equal to 0, greater than or equal to 0, then we will decrement y. So if it is greater means the southern pixel is closer. But when it is equal to 0, you can take actually any point. Both are same. Distances are same. It means you can take either southern pixel or northern pixel. So you can take any one. I am selecting southern one. So you have to include equal to also here. So I am including equal to. Otherwise, you should write equal to, select either this or that. Instead of that, let us include with southern pixel. So what is that southern pixel? Xk plus 1, yk will be decrementing. That's it. Now we have to simplify this one. So let us bring it back here. Now we will substitute these two things. This is xk plus 1. Xk is in subscript. Plus 1. X is incrementing. This is whatever y is decrementing. Let us substitute those things here in this function. So this equals, see, we will add these two. We have to add them first. So this is xk plus 1 whole square and this is also xk plus 1 whole square. So this is 2 times xk plus 1 whole square. Then this one is yk square, then this is yk minus 1 square. They are different. So first I'll take yk square, then I'll take yk minus 1 whole square. These two separately I have taken. And now this is also minus r square, this is also minus y square, r square. So this is 2 times r square minus 2 times r square. Now we know well that xk plus 1 always x increments. So I'll make it as, put it in bracket first, as in bracket, xk plus 1 is in subscript. So I'll just take out and say xk plus 1. So I'll say xk plus 1 whole square. Then what about yk? This is same. Now this is yk minus 1. So y is decrementing. So I'll put it in bracket, then I'll say yk minus 1. So this is our dk. That is fn plus fs is nothing but dk. So this makes our first equation, dk is equals to so and so. This is our first equation. And this is what we have to simplify. We have to simplify it, make it simple. Now, next important thing. We have a decision variable for current xk and yk. Who is a decision variable? Dk, which will help us decide whether to keep y as it is or decrement it. So if the result of this dk is less than 0, we'll keep yk as it is. Otherwise, we'll decrement yk. This is what it is going to help us. But once we have moved to the next pixel, again we need a decision variable for the next pixel also. Then how to get that? For that, you have to find out dk plus 1 also, means decision variable for the next pixel also. So now we will find out dk plus 1. For that, we will write down this one. Now, this is k plus 1. So this should become xk plus 1. Next pixel, for next pixel. Then I'll take this component as this is yk, next yk. Next yk means yk plus 1? No. Yk minus 1. So this is yk minus 1. Then I'll take this component as it is. This is also k. I should make it as next. Next means what? Yk minus 1. And this as it is. So you can see that I have taken the same equation. Just I have substituted xk plus 1 and yk minus 1 for the next pixel. Now, you know that xk plus 1 means always next pixel, always increment, because we are sampling x. So xk plus 1, that plus 1 becomes actual value plus 1. So let us make it as plus 1. So this becomes how much now? Xk plus 2. But what about yk minus 1? It may decrement or it may not decrement. So we cannot change that. So this becomes our second equation. So now we have decision variable for the current pixel xk, yk, and decision variable for the next pixel also. So we have two equations. Now we have to simplify further. We'll remove this one. I'll keep it on this side. Now if you see, this is the decision variable for the current pixel. Decision variable for the next pixel. Then from current pixel, can we get the next pixel? By adding something, we can get it. Yes. See, absolute result or equation for the current pixel, absolute equation for the next pixel. But we can do it relative. Means what? If you know the current decision variable, you can get the next decision variable. So for that, you need to know how much difference is in between these two, and you should add that one every time. So let us find out the difference between these two decision variable. So what we should do now? We have to find out dk plus 1 minus dk. We should subtract these two. So here I will write down dk plus 1 minus dk in these brackets. Let us expand it and write down this dk plus 1. And I'll take it in the next line here. And here I have to write down dk. So I'll expand this and write down dk. So this is dk plus 1 minus dk. I have to subtract. Now this will get simplified. So once again I am repeating. Listen carefully. We are devising or deriving Bresenham's circle generation algorithm using Pythagoras theorem. In that we are going to find out only 1/8 of a circle. X values will always be incrementing because we are sampling. Why? To decrement or keep it as it is, we have to decide. So what is the decision variable? Dk. For the current pixel. Next pixel, dk plus 1. But dk, okay, we know. We will find out. How to get the next pixel decision variable? We need to add the difference in that one. So we can, from dk, we can know dk plus 1. So for that, we are doing this derivation. Watch this. Now, we have to subtract this portion from this one. If all these values will become negative, 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 and this becomes positive. So you can see that these two gets cancelled. So I'll cut off this one and this one. That are gone. Now next step, we have to simplify. So I'll write down this again, once again, dk plus 1 minus dk. Now I'll take this portion and write it here. And I'll select this one and write it here. Now if I go on doing it, it will become very lengthy. So I'll do it at the same place. Further simplification, I'll do it here only. So I'll hide this. We don't need it now. I'll zoom it a little bit. Now watch this. I have to simplify this one square and this also, this one also, this one also. So 4 elements I have to simplify. I have to expand. Let us expand this. Here I got xk plus 1 to whole square. This is a plus b whole square, you know well. This is nothing but equals to xk whole square plus 4xk plus 4. But actually it is getting multiplied by 2. Let us do it here itself. So 2 into this whole thing becomes what? 2xk whole square, 8xk plus 8. So I'll substitute this one. I'll take out this and I'll make a space here. I'll take out this equation and substitute here. I have that one. Now y. No. First let us do for x, both of these x. Then we'll go for y. I'll select this one here. xk plus 1 whole square. Actually we need 2xk plus 1 whole square. So first xk plus 1 whole square. How much this is? This equals xk whole square plus 2xk plus 1. But this is getting multiplied by 2. So multiplied by 2, 2xk square plus 4xk plus 2. We have to substitute it here. We got the result, expanded form. Take it out, make a space, take this one, keep it here. Expanded these two parts or terms. Now we can cut off few things here. You can see that this is 2xk whole square, 2xk whole square. This gets cancelled and this gets cancelled. So I'll remove this one and remove this one. Now if you see, the coefficients are 8 and 4 and the terms are same, xk and xk. So if I subtract this if I cut off, this becomes 4k. And this is 8. These are constant values. If I cut off this becomes 6. I'll take out these also. Now let us bring them closer and this also closer. Have a look at it. Now we have to expand these terms. So let us select this term here. Yk minus 1 whole square. This is equal to yk minus 1 whole square minus 2yk plus 1. So take out this, make a space, and this portion I'll keep it here. Now in this, if you observe, yk minus 1 whole square, yk minus 1 whole square. This was already there. Just now we got this one. Now this can become 2yk minus 1 whole square. So I'll take out this and add here. So this becomes 2. So look at, keep it closer. Now we can simplify further. 6 plus 1 we can make it 7. Let us keep it as it is. Now we'll expand this one. Yk minus 1 whole square is equal to yk square minus 2yk plus 1. So we will remove this, make a space here and substitute this here. Now again, if you observe here also we got yk square, add these two. So I'll remove this and make this as 2. Now if you observe one thing, this is 1 and this is also 1. So I'll cut off this and cut off this one. So this one is gone and this is also gone. It's simplified a lot. Make it closer. Let us take it on this side. Now if you open the bracket, then this term will be negative, this becomes positive. I'll remove this bracket. So this is negative and this is positive. And remove this brackets also. Now in this, can we do any further simplification? How many terms are there? 1, 2, 3, 4, 5, 6 terms are there. No, this is the final equation. What is this? This is dk plus 1 minus dk. Now let us take out dk from here, move equal to sign here, and we'll write dk here. So this becomes dk plus 1 is equals to dk plus this entire thing. This means what? If you know the current decision variable for the current pixel xk, yk, then you can prepare the decision variable for the next pixel, that is dk plus 1. From current decision variable, add this to get the next decision variable. Now this becomes our third equation. Now in this, we have to further simplify this one based on the values of dk. You know very well that if dk is less than 0, greater than 0, what happens? So we have seen it here. I'll open it. See, if dk is less than 0, x will increment, y remains same. If dk is greater than or equal to 0, x will increment, y will decrement. We know very well that. So let us apply those two conditions on this one. So I'll write here dk is less than 0. If dk is less than 0, x increment, y remains same. So let us take this equation here, and in this we will substitute next x as xk plus 1 and next y, yk as it is. So let us change this one. So this is what yk minus 1 means next yk. It's not going to decrement, it remains same. So this becomes yk only. And this also becomes yk. This is already yk. What about xk plus 1? Already we have done it earlier. X plus 1 we have already done it. So this is further simplified. When if dk is less than 0. In this, if you observe, this 2yk square minus 2yk square, we can cut it off. Let us bring it closer. Cut off this one and cut off this. Then one more. Minus 2yk and plus 2yk. This will also cut off. This will also cut off. Entire thing is gone. Remove this. What is remaining? dk plus 1 is equals to dk plus 4xk plus 6. Lot of simplification is done. We got a simple equation now. What does it say? If you already know the decision variable, in that you add 4k plus 6, you get a decision variable for the next pixel. When to do this? If current dk is less than 0. What I should do when it is greater than or equal to 0? Let us do it here. What does it says? X should increment, y should decrement. Minus 1 should be done. So let us take this equation once again here. So x already we have done it. We have just xk. But we have yk minus 1. What we should do? We should write down yk minus 1. So let us change this. This becomes yk minus 1 whole square. And this also yk minus 1. Now, if you expand this, becomes minus 2yk plus 2. Directly have done it. Now you are used to with this one. I have directly done it. Now if you observe minus 2yk and 2yk, we can cut off this and cut off this one. So this is gone and this also gone. I can further simplify this one. This is 6 plus 2. How much it is? 8. Remove this 2. Now we have to expand this one. What that will be? 2y square, yk square minus 4yk plus 2. Directly you can do that one. So I have already directly done it. Now if you observe plus 2yk square minus 2yk, this gets cancelled, this gets cancelled. Then remove this one and this one. Now further simplify it. Let us bring it closer. 8 and this is 2. Add this there. So this becomes 10. Bring it closer. 4xk minus 4yk. So we can put it in bracket and bring 4 outside. This is the equation. So a lot of simplifications were done. Finally, we are with a simple equation says that if the current decision variable is negative, to get how to get the next decision variable. In that you add 4xk plus 6. And how to get the next decision variable if current decision variable is greater than or equal to 0. Like this. So these are the formulas. See, let me open this one. See, this is what you have done. Actually, you have first equation and second equation. You have subtracted these two equations and you got third equation. This was the decision variable for the current pixel, decision variable for the next pixel. You subtracted, did a lot of simplifications and you got this equation, third equation. In this, you are substituting the value of yk based on the current decision variable, yk as it is or yk minus 1. You are getting two different results. That's it. So this part is important for us. This portion is important. So let us put it here. I'll take it and keep it here. Now, we know the decision variable. We know how to get the next decision variable if you know the current decision variable. This is what it says. But what will be the initial decision variable? We need to start with some value in the decision variable. So for that, we once again use this tk. Now we need only this, we'll remove everything. We need initial decision variable from where we should start. So now listen once again. See, we have three things already. X, initial y and radius. What should be the initial decision variable? So let us see. See, initially you know very well that x will start from 0 because you are sampling in and it will be always incrementing. But y starts from where? Y starts from radius and it will be decrementing. We know the initial value of x and initial value of y. We know this one. So let us substitute in this one. So let us take an equation here, and in this, let us find out the initial value of a decision variable. So let us call it as d0. Now here, xk, what it is? 0. 0 plus 1 is 1 only. 1 square is 1 only. So this becomes just 2. Then there I have simplified. Now yk, it's going to be r square. Then yk minus 1 whole square. So this will be r minus 1 whole square. Let us open this one. This becomes what? R square minus 2r plus 1. R square minus 2r plus 1. If I open this one, now r square plus r square, 2r square, and this r square, 2 minus 2r square, this and this cancel with this one. Now if you remove these, you are left with 2 minus 2r plus 1. Let us bring it closer, and 1 you add it here. This becomes 3 minus 2r. This is the formula for initial value of a decision variable. So let us remove all these. We'll take up this one and put it here. See, these are the decision variables. Initially, decision variable will be this one, 3 minus 2r, whatever the radius is. In our example, we started with radius 7. So whatever the radius may be. Then every time how to get a decision variable based on this. If it is less than 0, next decision variable like this. And if it is greater than or equal to 0, next decision variable like this. And what about x and y? X starts from 0, y starts from radius. X will be always incrementing. Y will remain same or decrement based on this decision variable. If it is less than 0, remains there. Greater than or equal to 0, we can decrement it. Will decrement y. That's how. So the complete outcome of Bresenham derivation was just a decision variable. X and y we are sampling. X value sample, y is decided. Now let us write a program code for this one. So let us write a program code here. A pseudo code I am writing. Initially, x is equals to 0. Y is equals to r. Decision variable, let us call it as just d. We don't need d0 and dk, all those stuff. Just d. D is 3 minus 2r over. These are the initial. Now we have to plot the pixels. Based on this 0, r, we can plot 8 pixels. We have 1 pixel, we can get 8. How to get that 8? I'll show it at the last. You already know you have octants. That will do later. I'm saying just plot 8 pixel as a comment I'm saying. Now we have a repeating procedure for getting all the pixels. So it needs a loop. Let us write a loop. While x is less than or equal to y, yes, you have to go on sampling the values of s as long as x is less than or equal to y. When it's become greater, you can stop. Even in our procedure, it's sufficient to say x is less than y. Equal to also you don't have to do it. When it become equal, stop. You can do that. But I wrote it as x is less than or equal to y. Let us start. You need a body of a loop. And this what you have to do? Decision variable. So we'll check if d is less than 0. If d is less than 0, what I should do? I should modify d like this. I should get the next value of d like this. So I am ready for the next pixel. So first, who is modified? Decision variable is modified. Then, if it is less than 0, do you have to modify y? No. Do you have to modify x? X is always incremented, whether it's greater or less than or greater, always it is incremented. So let us not do anything here, but let us write else and in the body of else. Now if d is less than 0, this is the formula. Else means what? Else means it includes greater than or equal to 0. Then the d should be modified like this. So d should be modified. Y should be decremented. Y should be decremented. Then where is x incrementation? In both the cases, x is incremented. So let us do it here. Increment x. See, one thing if you observe, first we modify decision variable, then we are modifying x and y. Initially we had a decision variable, and first we modified decision, then we are changing x and y. Anyway, now we have to put the pixels. Put 8 pixels. So this loop will be repeating as long as x is less than or equal to y, and every time changing the decision variable and deciding the value of y, x is always incrementing and putting 8 pixels. So that's it, you have a program code. Now let us keep the program code here and we will run this and draw pixels. So for that, I'll bring back the graph here. Now I'll be tracing this program code. So for tracing, we should see how the values of x, y and d are changing. So for that, I'll prepare a table here, and in that I will write down the values of x and y and the d, x, y and d. See, remember, for tracing a program with a loop, you can do it with a table. You can prepare a table. And how many columns are there? 3. Why 3? Because inside the loop, how many variables are changing their value? D is changing, x is changing, y is changing. 3 things are changing. So I have taken 3 columns. 3 variables are there. Now, which one is x and y and d? First, I'll take d here. Then I'll take x and y. Why so? If you observe, who is changing first in a loop? D is changing first in a loop. So first make D. If you make D afterwards, then table will confuse you. You put them in the order in which order they are changing their value. Anyway, y is change and then x is always change. It can be at any place. So I kept x, then y. 3 variables are there. Now, let us trace this algorithm and draw pixels. These are the initial values. So let us label it as initial. When you are tracing in the table, you should also clearly know which are initial values and which are within a loop. Now, first start from here. See, this bar is showing the execution bar. The moment it moves, it's executed. Statement is executed. This is executed. So x becomes 0 there. X becomes 0. Then y is equals to r. What is r in our example? We are taking r as 7. So this is executed. Y becomes 7. I am taking as 7. You can do it for any radius. Whatever the radius is, you decide here. Then now next is decision variable. See, this is 3 minus 2r. R is how much? 7. 14 minus 14. 3 minus 14 is minus 11. The moment it is executed, this is minus 11. The next thing is plot 8 pixels. See, for x value as 0, we don't have pixel. I said already that this is 1. We are calling it as 1. We are not taking intersection points. We are taking cells. So we'll start putting pixels from 1 onwards. So skip this now. I'll do it fast now because I have to just do tracing of this one. X is less than y, 0 is less than 7. Yes, enter inside. D is less than 0. Yes, so modify D. Once this is executed, D is modified to 5, minus 5. I don't have to explain you how to get 5 out of this one. So this is 5. This is 4 into 0, 0 plus 6. And this is minus 11 plus 6 is minus 5. That's how we got minus 5. This is over. Now after this it goes here. Then x plus 1, x is incremented. That's it. Then where is y? See, it has not entered into else part. Y is not decremented. We'll take same y, 7. Then plot 8 pixels. But we'll plot only 1 pixel. What is that? 1 comma 7. The moment it is executed, we have 1 comma 7 plotted here. Continue. X is less than equal to y, 1 is less than equal to 7. Enter inside. D is negative. Yes, D will modify. 4 into x is how much? 4 plus 6, how much? 10. So minus 5 plus 10 is how much? 5. D becomes 5. Now it has not entered into else part. Here it has came. Now x plus 1, x is incremented. What about y? Y remains same. Now plot 8 pixels. Where? 2 comma 7. 2 comma 7 pixel is plotted. X is less than y. Yes, enter inside. D less than 0? No, it enters here. Now D is modified by using this formula and the result is how much? Minus 5. Y is decremented, it becomes 6. X is incremented, it becomes 3. It's always incrementing. Plot 8 pixels. So we are plotting just 1 pixel there. For what? 3 comma 6. 3 comma 6. Continue. 3 is less than 6. Enter inside. Now decision variable is negative. So enter inside. Now the new value is how much? 13. X is incremented. Y remains same. 6 only. Then plot 8 pixels. We got 1 pixel there. Then still 4, 6. 4 is less than 6. Enter inside. Decision variable is positive. Enter here. Decision variable is changed to 15. Y is decremented. X is incremented. Plot 8 pixels. 1 pixels we have plotted. Now if you see, we should stop here because we have came at 45 degrees here. The remaining part is the another 1/8 part of a circle. Now if you observe, x and y became equal. We should stop. But actually I have written the code less than equal to y. We get one more extra pixel that is in this quadrant. So that will be the replica or mirror pixel of this one. Here we get mirror of this one. Just watch this. Less than equal to y. D is less than 0. No, it's greater. D is modified. Y is decremented. And x is incremented. Plot 8 pixels. So we have this one. So we got one extra pixel here. Now, x is less than equal to y. No, x is greater. Come out of this program. So the complete execution I have shown you. Now, we have the code. We have seen its execution. But one thing remaining. What is that? Draw 8 pixels. How to draw that? So for that, I'll remove this. I'll bring that bigger graph here. This is the bigger graph. We have done only this portion of it. 1/8. Now we need remaining. So we have to plot 8 pixels. So it is inside the loop. So it will be doing repeatedly all the pixels. And here this was for initial. I'll show you how to draw those 8 pixels. So instead of here, I'll show it here. I'll make a space here. Here I'll make a space and show you. Actually in loop you'll get all. Anyway, the first one, put pixel x comma y. This is the actual pixel that we are getting in this quadrant. This one, we were starting from here. In this quadrant we were getting. But actually for a circle, octants are used. Means from this pixel you can get this pixels in other octant also. So for that what you have to do? You have to swap x comma y. Put pixel y x. X comma y was that one. Y x, you will get this octant. This octant. Now it has become complete quadrant. Now let us go to this part. So for this, what I should say? Here we have x comma y. So you should say what? Minus x comma y. So you will get this octant. This octant. So minus x comma y will give you that octant. Then in that quadrant remaining part, next octant is just swap these values. Then you have to come in this quadrant. So you have to say minus x minus y. Both are minus here. So this portion will get this one. minus 6. So minus 6 minus 5. Then swap this, you get another octet. Then the fourth quadrant, you will get this octet first. So there x is positive, y is negative. X is positive, y is negative. Then swap this first minus 5, then x, you get another octet. That's how 8 pixels make a complete circle. But this is with reference to the origin at this place. But we wanted a circle with this center at some xc and yc. We got it with reference to origin. Then for that, you should add xc, yc to all these x and y. xc plus x, yc plus y. Here also xc, yc is added. Wherever minus was there, it was subtracted, obvious. So I have done addition of xc and yc to all of them. Then these points, you'll get them here. That's it. I have shown you the problem with polar coordinates and derive Bresenham's algorithm. In that, the major part was a decision variable that was deciding whether to decrement y or keep it same. From that, we wrote an algorithm. Algorithm is very easy. Then we substituted the values and saw the tracing of an algorithm by putting the values there. And then we have plotted all 8 pixels. That's all in this lecture. If you want a similar lecture in this style of teaching, you can mention the topic. I'll prepare a lecture on that topic. Don't mention the entire subject. From any subject, any tough topic you want me to make a lecture on it, I'll prepare it. That's all in this lecture.